a certain number of spherical drops of liquid of radius r coalesces to form a single drop of radius r and volume v. If T is the surface tension of the liquid, then okay. So if 2 to 3 spherical drops, they are going to collide and they are going to form a single drop. Okay. What if T is the surface surface tension of the liquid? Then we need to find the energy here. Okay. Then we know here that when multiple drops merge, the energy released is the difference between the initial surface energy and the final surface energy. The volume of the liquid remains constant. The volume will not change. Initial and the final energy we need to find, and we need to find the difference of that one here. So here the initial energy is denoted by the symbol. If I'm going to denote this one as, that is E1. E1 is equal to 4 times pi n into r square into t, where n is the number of drops. If B is the total volume, then we can write V is equal to 4 by 3, it's a spherical, that is pi r cube into n. Thus, we can write 4 pi into r square into n, which is equal to 3V divided by r. Then E1 is equal to energy 1 is equal to, that is 3 into V into T divided by R. Then E2 we can write the final energy. E2 we can write it as, E2 is the final energy. We can write that one as 4 pi r square into T. Given that V is equal to same, that is 4 by 3 pi r cube, pi into r cube. Then we can derive this one as 4 times pi r square is equal to 3V divided by r. Therefore, the final expression of the E2 will becomes E2 is equal to 3 into Vt divided by R. The energy released, which is the difference between the initial and the final, that is E1 minus E2 is equal to 3 into V into T into 1 upon R minus 1 upon capital R. That this we can see in the option, that is 3Vt 1 upon R minus 1 upon R. Option C is our right answer.